Hey guys, Ivan from PARSIQ here, and today I'm happy to greet you at our workshop, which we are holding for Reactive Basics. So today I'll share some of the concepts of Reactive Smart Contracts for our hackathon participants to start building. So as you all know, we are holding a hackathon right now. We started it a week and a half ago, and it still has 7 weeks to go. So if you're not aware of that, please check out all the links and join our hackathon. And if you are, then let's talk about how to build using Reactive Smart Contracts and what to build. So today I'll share a few ideas on what can be built with Reactive Smart Contracts, where to go to start building, and also I will share some details on our first bi-weekly challenge, because as you might know, we have several tracks on our hackathon, and for all of them, the deadline is in the end of the hackathon, except one, which is bi-weekly challenges. And for bi-weekly challenges, each 2 weeks, we present a new challenge, and the deadline is in 2 weeks. So on Monday, we've presented the first challenge, and that's what I will talk about today. Also, let's make it as interactive as possible. So feel free to ask any sorts of questions. I'm here for you. I'll try to answer all of them. And yep, let us start, and let me show you a few schemes here, which are pretty useful for explaining the Reactive Smart Contracts basics. So the first thing I want to share is like what Reactive actually does. I believe some of you have seen our previous workshops and have taken a look at our docs and bounty challenges. So I will be pretty short here, because in case you already know that, I will just shortly quickly reiterate on that. And in case you don't, I will refer you to our previous workshops and documentation, because we try to make it as clear as possible on our educational content and on our YouTube channel as well. So what Reactive basically does, it's an EVM chain, it's Solidity Smart Contracts, and it's an on-chain if this, then that. So some action happens on-chain on one of the existing EVM chains, for instance, Ethereum or Polygon. Reactive Smart Contract reacts to that, checks some conditions, and then runs the transaction on the destination chain, which might be the same or might be different. So in that particular example, we see that Ethereum network serves as the origin chain, and then the Polygon network serves as a destination chain, which means that we are monitoring events on the Ethereum network, and then we are doing post actions on the Polygon chain. So you can see here that some event is happening on the origin smart contract. We will be following this terminology further, and we are following this terminology in our docs. We call the contract on which we're monitoring events the origin smart contract, and we call the contract with which we interact, to which we send transactions, a destination smart contract. And respectively, we call them an origin chain and a destination chain. Yeah, so here some event is happening after some function is called on the origin smart contract. The Reactive Smart Contract reacts to it. Then you can see 3 dots there, which represent checking some conditions, running some logic. This logic might be just simple checks like if this and that, but also it might update the state of the Reactive Smart Contract, because the same way as any Ethereum smart contract, a Reactive Smart Contract, it has its state. It can store some values and other stuff. And yeah, it can process arbitrary logic using Solidity. And as a result of the execution of the logic that you specify in your Reactive Smart Contract, it emits the callback. And when it emits the callback event, callback is a keyword in Reactive. It means that we actually call the function on the destination smart contract. Here, the function is red, and the callback event is red. So that represents that we basically calling this function here. So that's basically what Reactive does. And the application of this workflow are pretty unlimited. One of the reasons why we started this hackathon is to explore more of those applications. But some of the basic examples can be found on our docs already. So let me share my screen and share those examples with you. Okay, I believe I'm sharing this Chrome tab right now. So this is our website, Reactive Network. Let's go to the docs. And now let's go to demos. So all these links, they lead to some GitHub code. You can check it here on, or you can check it on GitHub. We will take a look at all of them. So first of all, we have a basic demo. You can check it out just to implement the same workflow that I've just shown on this basic scheme. Then we have a faucet. So a faucet, it monitors the events of you depositing Ether, Sepolia ETH to our Sepolia contract. So you send Ether to our Sepolia contract, then the Reactive Smart Contract monitors this and gives you React on reactive chain. So that's how our faucet works. And also that's basically a Reactive Smart Contract. So here the origin chain would be Ethereum Sepolia and the destination chain would be Reactive Network, because Reactive Network is also a Solidity, an EVM chain, and it can receive callbacks the same way as any other Ethereum chain. In that case, this callback being us sending you some React tokens for you to be able to deploy and run Reactive Smart Contracts. Then the next one is the one we'll discuss in more detail today. This is the Uniswap stop order demo. In this particular example, we are monitoring Uniswap version 2 pool. And this pool, it emits sync events whenever there is a trade on this pool. So we're monitoring those events. And when those events happen, the Reactive Smart Contract is triggered. Then this Reactive Smart Contract, it sees and calculates the exchange rate based on how much assets are in like both parts of the pool. And then when this exchange rate reaches the set threshold, the trade is executed. So basically, that's how you would expect a stop order to work. Currently, stop orders are obviously available at all the centralized exchanges. It's pretty hard. It's pretty easy to implement them on a centralized exchange where you control all the process, but it's a bit harder to implement it on a decentralized exchange. And that's what we do in this particular example. So it works for Uniswap version 2, but it also might work for whatever exchange of your own choice. You just need to develop or reuse our Reactive Smart Contract and the callback smart contract. We'll dive into detail a bit later. So we also have some examples here. You can check them out. You can check the code, but I will also would like to share the examples that we got on our bounty program, right? So let's go here to our GitHub. This is our GitHub. You can take a look at it. And now I wanted to share this particular repository here. And this repository was used for our bounty program, which we ran this summer. And we had several bounties. We asked our bounty participants to implement some particular use cases. And most of them were implemented, and they were implemented pretty well. So you can take a look at those code examples for an inspiration of what can be done using Reactive Smart Contracts and how it can be done. So let me just quickly go over those examples for you to have a basic idea of what can be implemented and what have been implemented already, right? So first, you can see an example of automated prediction market here. In that case, it means that when the prediction is made, then the event of interest is being tracked by the Reactive Smart Contract. And then when this event happens, the price is distributed automatically based on the outcome of the event for which the prediction was made. So here, Reactive Smart Contracts are used for automating this process. Same way here with the automated fund distribution. So there is a wallet to which some funds are sent, and they are automatically distributed to several people based on the preset values, right? Another example is like all the other examples, they are reactive smart contracts and smart contracts. They don't have any front end, but this is the application for our dApp, decentralized application bounty, and it also has front end. You can check out the video in there as well. So it's ERC 6551 with a reactive smart contract. ERC 6551 is an NFT account, so an NFT which also can own assets and act as an account. And in that particular case, the events of ERC 6551 account creation are monitored, and the automation is works with that. You can check out it here. Another example is a reactive governance system. You can see it in this example. So in that case, the voting events are monitored, and based on those votes, when the threshold for the number of votes is reached, the decision for which people were voting is executed. The next thing is a pretty interesting one, because it can be used as is, or it can be used for an extended number of use cases. It's the automated one-step swap. So here we are monitoring the approval event, and when this event happens, we execute the swap. What does it help to achieve? It helps us to achieve reducing the number of steps for a user on a DEX from 2 to 1. So as you all know, when you're using a DEX, or when you're using decentralized loan, or when you use tokens in any other way, more or less, you have to first approve the tokens, and then with the second transaction, you execute the action that you're going for, right? So anyway, you have to sign and send 2 transactions from your wallet. So you need to go through the whole process in your MetaMask or other wallet twice, which is not very comfortable, especially if you are a first-time user. You might be pretty confused with that. So let's say you're developing your own DEX, and you want to reduce this process for your users from 2 to 1. In that case, you can use this setup. You'll be monitoring approval events. Then you will be executing the swap using a reactive smart contract when this reactive smart contract sees this approval event. And last but not least, automated insurance payouts. So when the insurance event happens, the payout is done. So I wanted to list all those examples because this is some good code created by our bounty participants, and you can use it as an inspiration. You can take a look there. Also, like if you're interested in an in-depth explanation, you can see the video with me going through the code of each of those bounties on our YouTube channel. So yeah, you can use this as an inspiration and as a way to learn how to use reactive smart contracts. Now, let me take a look at the chat to make sure. No questions yet. So I will be proceeding with the next part of our today's talk, which is basically I will show you the code. Just give me a few moments to switch windows. Okay. I have to stop demonstrating this one, and I will present a new one. Okay, I believe now you can see my IDE here. And you can see our Reactive Smart Contracts repository here. So you can clone the same repository and you can take a look at the same code and you can actually run it. We made sure that it all works. Like it worked before, but we made sure again, because like we had to update, we updated our system smart contracts, and I will talk about that because we implemented the payment model as well. And yeah, let me go straight to the examples. Also, I won't be running those examples today because I have already done it, I believe, twice on some of our workshops. So you can see it on our YouTube channel. Like the last one was our workshop with it blocks. And so today I will try to show a bit more code, and I will try not to spend our time on actually running it. Otherwise, we won't be able to take a look at all of this. So first of all, let's take a look at the basic example, and then we'll discuss the Uniswap stop order example, because it's a pretty important one. And I wanted to show you this code as well. By the way, if you're following UFC, you know that this Saturday, Merab Dvalishvili from Georgia won the championship belt. And like one of the things he's promoting on his Instagram page is this water, Nabeglavi. So I decided to drink what our Georgian fighter recommends. Okay, so let's start with this basic demo setup here. It pretty much corresponds to the scheme that I've shown you before with the origin contract, reactive contract, and destination contract. So origin contract here being this L1 contract, reactive contract is reactive contract, and then destination contract is callback contract. So we will be using those terms interchangeably, destination and callback, because what happens here is we are sending a callback to the destination. So I will also be pretty brief here because I've shared this example on the workshops that I've mentioned, on 2 of them. So I won't go into much of detail. I'll just show it super briefly. So what we have here in the origin contract, we just receiving some ether with this function. Then we're emitting the received event, and then we're transferring those funds back to the transaction origin, which is to the person who sent them, right? So what we're interested in is emitting this event here. Then the reactive smart contract, it's here. Let's take a look at it. So it has some predefined stuff here that you can use as a boilerplate and reuse, and basically clone the repository and leave most of this stuff there. But what is specific to our particular example is this React function here. So what happens is we are monitoring this event, the receive event from the callback contract. And whenever this event happens, so you can see that we are subscribing to this event here in the constructor. And basically in every constructor, you more or less will subscribe to some events, because you're that's the purpose of the reactive smart contract, is to monitor some events. And by subscribe, I mean call the subscribe function of the system smart contract. So there's a system smart contract on Reactive Network, and it has subscribe function, and for your contract to receive those events, you need to subscribe to them. So basically here you specify, here you call this function, right? You specify the chain. So in this particular example, we are monitoring the Sepolia chain. Here you have the contract to which you subscribe. Here you have the topic 0 of the event that you're interested in. And here you use reactive ignore to ignore the other arguments of this call. And here, so this service address here, it's the address of the system smart contract. So here you can see that we are treating it as a system smart contract. And then we're sending we're calling the system smart contract with this payload here, which means we're subscribing to the event of interest. And that's more or less what's happening in our constructor. So we've subscribed to those received events. Then when those events happen, this React function is called automatically by the Reactive Network. So this is also a specific function here. You can add your own functions if you need, but this particular right here, it's called automatically whenever those events occur. So, and what's happening here, we're just emitting the event with all the data for debugging purposes, and then we are checking the condition that the transfer was bigger than 0.1 ETH, just to add some condition check to this boilerplate example. And then if this condition is met, then we send the callback. So the callback is with this payload, and this payload is basically calling this callback address, a callback function on our destination smart contract, on our callback smart contract, which we will take a look at in a second. And yeah, you can see the chain ID specified here, the callback address, which was specified in the constructor here, right? And then the gas limit and the payload. So whenever the event received happens, which is whenever we send funds to the origin smart contract, we have this function here reacting to it and sending a callback, which is calling callback function on destination smart contract. And this is the destination smart contract right here, also called callback smart contract. It has this callback function, and it basically does nothing except for emitting this event, which is for the purposes of us making sure that everything worked. So you can see this setup working, as I have said, like with all the transactions. I'm showing it on the previous workshops, and today we won't spend time on that because we want to go deeper into the code. One important detail that I wanted to share specifically is this address here. So as you can see here, here we are passing 0 address as an argument for this callback function, right? But what this callback function will be receiving here is not a 0 address, but a sender address, which is the address of your deploy address. So the address from which you deployed this reactive smart contract. We have this described on our docs, and you can find the examples of that being used on our repositories. Just note that on the level of Reactive Network, this first argument here is replaced with the address of your virtual machine, of your deployer. Okay, and that's it more or less for this simple example. Let's also take a look at the README here. You can see all the explanations here with the schemes, and then you can see all the build instructions and how to deploy those smart contracts and how to make this work. You can just follow these instructions, take a look at the transactions on Etherscan and on ReactScan, and play around, make sure that you understand everything, try to change some conditions, add some logic. So that's pretty simple here. What happens is we are deploying the origin smart contract, right? Then we deploy the destination smart contract. Then we provide payment, and that's what I will need to talk about specifically. And then we deploy the reactive smart contract here. And then we send some funds to our origin smart contract to make sure that it all works. And then we can see all the transactions on ReactScan and EtherScan. So another thing that I find pretty important to talk about today is this callback payment. So this is the addition that we've made recently. We've actually added an economic model to our testnet. So on our bounty program, we had this model where we just prepay all the transactions for you. So we take the Sepolia ETH that you bring to the faucet, and we use this Sepolia ETH to pay for all the transactions for you. However, in case some contract has a lot of callbacks, we run out of this Sepolia Ether, and that's not how it's supposed to work, obviously. So like it was just the first iteration, so that's okay. But now we're further down the road, and now we actually have this economic model here. So for your economic model, for your smart contracts to work, you need to send your callback contract some ETH balance, and our proxy smart contract will be taking this Ether as a payment. And you can see here how to do it. In that case, it's Sepolia Ether, so it doesn't cost money, but obviously on the main nets, it will be some real money. And that also answers the question, which we have been asked a few times, who pays for the gas? Well, you, starting from now, you can pay for your own gas thanks to the economic model that we have now. So you can see the short instructions here. You can see the link here where we describe all the process in the docs. Okay, so that's what I wanted to share here for the basic example. Now let me take a look at whether you have any questions. No questions in the chat yet. So let me go back to our code, because that's what we're here for today. And let's take a look at the stop order. So for the stop order, you can check out all the README instructions. This setup is a bit more complicated because we are not monitoring some template smart contract, but we're monitoring a real testnet Uniswap pool. So first we create a pair here. We put some money to that pair. We deploy a token first, right? Then we deploy the second token for us to have a pair of 2 tokens, right? Then we create a pair using the testnet Uniswap version 2 factory. Then we deploy this callback contract, which runs the transactions on our behalf. Then we provide it with some money, the same way I said before. Then we transfer liquidity to those pairs for our pool to have some money in it, for us to play around with it, and for us to see the actual exchange rate changing. And then we deploy the reactive smart contract here. And then we approve in some funds. Then we send in some funds. And then when we send funds, we actually execute the swap here. And after we execute the swap, the exchange rate changes because we're executing a swap. And then when this happens, the reactive smart contract sees the exchange rate change and it executes the final trade, which is a stop order on our behalf. You can try all the setup here. It looks pretty cool when you actually run it. And let me dive a bit into the code. So for the token, obviously, you know what it is. For the pair that was created, you also can take a look at the open sourced Uniswap version 2 code. Also, you can replace it with any other DEX code of your choice. You will just need to update the reactive and the callback smart contract based on that, but generally it works with any pool, or not even just the DEX pool, but it also works with Aave, Compound, and all the other types of projects. So you just need to define the condition which you want to be met. In our case, it's exchange rate reaching the predefined threshold, and you need to specify the action. In our case, it's a swap. So let's take a look at what the reactive smart contract does here. So it also subscribes to the event here, and it subscribes actually to two events. So first of all, it subscribes to the event of exchange rate changing, which is a sync event on a Uniswap pool, right? So you can see that it subscribes to the pair smart contract here with a Uniswap version 2 sync topic 0. But also, after the stop order is executed, we need to put this reactive smart contract on hold so that it doesn't try to execute more stop orders, because we actually just need one. And that's why it also subscribes to the stop order, which is our callback contract with this stop order executed topic 0. And that's what happens in our constructor, basically the same way as before, just 2 subscribes instead of 1. And also we can take a look at our React smart contract React function here. So what we're interested in is here, if the stop order is executed. So if the event that happened and that triggered this function is our stop order event, in that case, we're just finishing the work of this contract. We're putting it on hold, stopping it. Here, this is basically the first branch where we're monitoring the pair smart contract. And whenever there's a sync event, we check the conditions, and we call, no, we don't check the conditions because we check it on the side of the callback smart contract. We'll take a look at it in a moment. We are sending the callback, we're calling the stop function on our stop order callback smart contract. Okay, so as you can see, it's pretty simple here, because most of the logic, it lays in our callback smart contract, and like a lot of work that you will be doing on the hackathon or when using Reactive for your own purposes is like these callback smart contracts, where you actually put the actions that you want to be executed on the destination chain, right? So let's take a look at this particular example. So as you can see here, it's inherited from the abstract callback, the same way it was here in this demo, right? And abstract callback is our predefined smart contract. You can use it, and I encourage you to use it, or you can try to change it, but that's not recommended because it basically just implements the payment functionality here. It's inherited from abstract pair here. Let's take a look at abstract pair. You can see that it implements the paying functionality. We won't be covering this in detail today, but we'll talk about that later. Probably if you have some questions, ask them in the chat, in the Telegram chat as well, and we'll answer them, like if you want to know how it works. But anyway, you can just read the code or take a look at the docs. It's pretty simple. Anyway, the reason for us to use to inherit from abstract callback, which inherited from abstract pair, is for our callback smart contract to work correctly with our payment model. So yeah, it's inherited from abstract callback. And what it does here is it executes this stop order. So as you remember from our reactive contract, we're calling this stop order here. So the arguments are the sender, as I have said, the first argument of the function that our reactive contract executes is always your address, the address from which you deployed the reactive smart contract. It's done for authentication purposes, so that you can add here the check that only your Reactive Smart Contract can call this stop order here. Also the pair address, the client, which token is being sold and which is being bought, coefficient, which is for our price calculation, and threshold, which is also for our price calculation. So I won't go here line by line, but basically what happens here is we are calculating the exchange rate based on what we've seen in the sync event. So yeah, let's take a look at the sync event here again. As you can see, we have the coefficient and threshold here. And yep, we pass them to our callback smart contract. You can also take a look at the build and run instructions to see how this setup works. And then we check that the threshold has been reached. Then we check which is token being sold and which is being bought, because like we have specified it in our stop order setup. Then we check all the basic things such as an allowance and balance, and then we execute the transfer from the client to this callback smart contract. Because if we take a look at the swap function, it only works with the funds that it only can be called and can take funds from the message sender, not from the transaction origin. That's why we need to transfer funds first to the callback contract, and then from the callback contract we are calling the swap function, right? And then after all the checks are done, we execute the swap by swap exact tokens for tokens on our pair contract. And after that, we emit in the stop event. And this is particularly important because this stop event, it's also monitored by our reactive contract here. And as you remember, after that, we put this contract on hold to make sure that it doesn't send the callback again and again. So yeah, I hope this sheds a bit light on that. The purpose of that explanation was not to explain in detail how this particular smart contract works, but to showcase how reactive smart contracts can work in general and to demonstrate how they can implement a simple functionality of monitoring an event and then doing some checks and then doing some post actions. And yeah, also show a few things in the code, such as like monitoring this event in order to affect the state of this reactive smart contract to make sure that it doesn't run again and again. Now, let me take a look at the chat again. Yep, no questions there. So then another thing that I wanted to share today is where to start. So I believe I've also shared it on our starting workshop a week ago. So I won't go into a lot of detail here as well. But generally, you can go to our docs to the getting started page. We made sure to put all the needed information there. So you can see the Reactive Hackathon information here. You can see the information on how to get Copley testnet. So Copley is the name of our testnet React for you to deploy and interact with those reactive smart contracts. You can see information on how to deploy your first reactive smart contract, and basically that leads us to our educational course, which is there. It has a lot of good explanations. You can take a look at it as well. Then you can see the link to the reactive demos that I've just shown, the Uniswap version 2 stop order and all the other stuff, and also the link to education. So basically, you can start here, and then the last thing I wanted to share is our bi-weekly challenge. So let's go to Dora hacks here. to our Reactive Hackathon. So you can find all the links here as well. And here you can also find the link to our boilerplate repository, which is basically an almost empty repository with just this basic example that I've just shared. This is just the code for you to start with. It has all the build instructions, it has all the necessary imports, and it has our system smart contracts and abstract callback, all the other stuff for you to inherit from here. So I encourage you, when you start developing your own smart contracts for the hackathon, to just clone this repository and start not from zero, but from this setup here. And then let's go to our tracks. So as I have said, we have 5 tracks. I've already talked about them in detail a week ago, so you can check it out on our YouTube channel. And today I wanted to talk about this one in particular. So it says here then on the 2nd, 4th, and 6th week of the hackathon, we present bi-weekly challenges, and the 2nd week is this week. So we presented the first challenge on Monday, and you can see it here by this link. Also, you can go to it from here, from bounties. We made sure so that you can find it anyway. Yeah, and this is our first bi-weekly challenge. Challenge 1, Reactive Bridge Decentralized Application. So it has the description here. Basically, we're asking you to develop a bridge that will use Reactive Smart Contracts for notifying the destination contract to release the tokens when the tokens are sent to the origin smart contract. So that's not a lot to explain here. I believe you've seen bridges before. Obviously, they worked differently than what you're gonna be building here. And also they work in a much more complicated manner than what you're gonna be building here. So here, basically, you just need to create, I believe it's gonna be 3 contracts, give some tokens to them, use 2 different chains, send tokens to one contract, then the reactive contract reacts and tells the destination contract to release the tokens, and after that, those tokens are released. That's pretty simple. In case you have any questions, please feel free to ask them in the chat. As you can see here, in our Telegram chat and Discord chat, our community members and hackathon participants were asking questions, and we're trying to be as responsive as possible. And yep, so these requirements here, they're more or less the same as for the main tracks, and we've discussed them in detail a week ago. The only difference is this particular challenge must be submitted before September 30, because those are bi-weekly challenges. We created them for you to be able to you to have incentives to start developing already, to try some stuff out, and probably to get the prize. Because like a lot of people, they tend to postpone stuff to the end of the deadline, to the end of the hackathon in this example. And we wanted to make sure that you have like a good chance to start playing around with our tech before that, figure out some simple things, probably build some simpler applications before you start building bigger applications for the open track, for the DEX track, for the Pangolin track, for the template deploy track, which are definitely more complicated and which will have more competition because of the bigger prizes and stuff. So yeah, just make sure that you submit your application in 2 weeks from its start, which is September 30. Oh, yeah, sorry. I was sharing my code all the time, so I will need to switch back to the hackathon page. Sorry about that. Yeah. So I was talking about our hackathon page here. So this is our main page of Door Hacks. You can see the boilerplate repo, which I talked about right here. You can see the tracks descriptions here, and I was talking about the fifth track, which is bi-weekly challenges. And here you can click this link, or the same way you can click here this link to get to those challenges, see the challenge one, and here is the description of this challenge, and here's the deadline and all the other requirements that we've discussed before. So in that particular example, unlike for the open track or for the Pangolin track, you don't need to come up with your own stuff. You just need to implement the use case that we offer. And in that case, it's simpler, but obviously you still need to develop the code to make it work and to present it well. And that in that case, you will win, you will compete, and the best submission will win the 700 USDT that we put up as a prize here. Yeah, thank you for telling me about that, BTC Alchemist. And yep, I believe that's it for today. I will stay here for a few more moments in case you have any more questions. So once again, thank you for being here with me today on our workshop. Please feel free to join our hackathon, so you still have a lot of time. So also feel free to share information about our hackathon. It's a great opportunity for beginner and middle-level Solidity developers to learn to build some code. Also, our stack is generally Solidity, so it all transfers well to your resume and to your GitHub account. So you can just build some Solidity code, have some fun, win some prizes, talk to a great community. Because fortunately, our community is pretty responsive, and even before I answer questions, sometimes our community members answer questions. So yeah, you can have a lot of fun, some learning, and potentially some money, as well as your friends. So feel free to share this information with your developer friends as well. Okay, and since we don't have any more questions, thank you guys. It's been a pleasure, and have a good evening. Take care.